Okay, we'll complete the question that we stopped the last time. Right, we stop at this question. Can either I use RCB square or can use area under the graph. Both will give the same answer. Okay. X, Y, Z each have capacitance 10 microfarad. We put 12 volt across AB. So we want to determine the charge on X. What do I do? Any suggestion?
Charge
Each of them 10
CV,
microfarad. You want the charge on X.
CV.
Right? There's 12 volt across AB. So combine these two together. Right? Each of them is 10. So you add them up is 20. Right? So that is our resultant. Right? Replacing this with that. This one is still the same. And there's 12 volt across that. So all we need is find the charge on the resultant of one of these capacitor, or replace it with the resultant capacitor. Same thing. The charge will be the same. Right? PD across combination, 12 volt, V10, V20, and we use Q equals to CV. V is Q over C. Okay, that's your C. So let it be Q over that. Change to SI unit. Q over 20. Change it to SI unit. And simplify it. You get 80 microcoulomb. Right? Whether it's on resultant or on either one of them, it's the same. Both of them have the same charge. Can? Okay. This is 2011 November, October, November, paper 43. State two functions of capacitor in electrical circuit. Can remember?
Two function. I forgot.
Right? Store energy, electrical energy, separate charge, not store charge, no, not store charge, separating charge. Two enough already, blocking capacitor, rotating oscillation, that one you don't study, don't bother, just smoothing, which you study tonight. Hopefully we got time. Preventing spark, timing circuit. Okay, so all these two you study. This one will be studied later on. Others don't bother if you don't know how it works. But it's not wrong to put it there. Three uncharged capacitors C1, C2, C3 are connected in series as shown in the figure. A charge Q plus is placed on plate A, plus plate A of capacitor C1. State and explain the charges that will be observed on the plate of the capacitor. You may draw if you wish. Right? So they say make it draw easier rather than express. When Q is placed on A, minus Q is induced on the opposite plate of C1. So the electron will go there. This will be Q plus, induced Q plus, and induced minus Q1, and so on. And equal charge Q1 is left on C2. By charge conservation, charges are minus Q1, Q minus Q1, Q minus Q. Okay. Use your answer in one to derive the expression of combined capacitance of the capacitor, right? This one is just draw lor. If you want draw so that you know what is happening there, replace these three, you want capacitor, right? V equals V1 plus V2 plus V3. We are just using Q equals to CV. From here, Q is C is V, and this is Q C1, Q was C2, Q was C3. I just using this formula. Cancel Q, we get our answer. Okay, deriving
Yeah.
required to know. Capacitor of capacitance 12 using a battery of 9 volt is shown in figure 4.2. S1 is closed and S2 is open. This is closed, this is open. The capacitor now is connected from battery by opening S1, so it stores the charge, it's fully charged. Calculate the energy stored in the capacitor. Straightforward, memorize formula only. R CV square. Change it to SI unit. V square, 9 volt. Okay with that?
Mm.
12 capacitor is now connected to the uncharged. This is uncharged. This is charged. So this one remains open. This one is closed. Suggest why the value, the total energy now stored in two capacitors is stored in here is that. We calculate the first one stored there is there. Suggest why this value is different from the answer in one.
Is it because it's in parallel? I mean, yeah, yeah, parallel.
No, the charge is moving, so current is moving. So energy is
Oh,
lost in the wire. Remember that,
okay, okay.
right? Because a lot of charge is moving. So it depends on the resistance of the wire. Wire has low resistance, so the charge is moving very fast. A lot of current. So that's why energy is dissipated. Okay, we have completed. Let's go to AC now. Okay, topic 21. I didn't cover magnetism first, partly because alternating current, they have removed transformer part, so it's more like electricity lah. So I would combine the electricity together lah, because exam they will try to combine one or two topics together lah, so that they don't have to have a separate question for different topics lah. Okay, electric generation, transmission and distribution. Power plant produce alternating current. Transformer is used to step up. Right? You step up first, then pylon is connected, transmit it. Before I reach the house, is transformer steps down, and then before I reach the house, there's a transformer here. Step down again to the value that is required by the house. Right? Even in your charging of your handphone there, right? The transformer will probably be there lah. You want DC to charge the battery. Page 200. But we're going to cover characteristic of alternating current. Right? There's the alternating current. there's an analog low voltage source, right, or power generator or oscillator. That's, a, that's how you represent the current. Some of terms we will come up. Distinguish between peak and root mean square value. For resistive load, memorize mean power is mean power equals to half maximum power. And then we will look at mean current, how to find mean current or average current. Right? These are various graphs we encounter. Transformer is normal already. It's removed from the syllabus, so we don't have to worry about it. Last time the syllabus is 24 alternating current, now changed to 21. So without a transformer, we are now, after that, we will look at rectification and smoothing. Right? Basically, we are changing AC to DC. Right? We are looking at half wave, right? There is smoothing, full wave, right? This one is normal. Don't worry about textbook, there is the syllabus. I go briefly review your O level or IGCSE or SPM syllabus on transmission of electricity. That's the neat thing. You can use I or you can use V. Both of them have the same formula for alternating current. Alternating current electricity is the type of electricity commonly used in homes and businesses throughout the world. While direct current electricity flows in one direction through a wire, AC electricity alternates its direction in back and forth motion. Direction alternates between 50 to 60 times per second. Right? Malaysia is 50 hertz depending on the electrical system of the country. Different country have different system. AC electricity is created by AC electric generator, which determines the frequency. Right? It's a AC electric generator that determines the frequency. What's so special about AC? Electricity is that voltage can be readily changed. You can step it up, step it down, thus making it more suitable for long distance transmission than DC electricity. DC you cannot change it. AC you can change it. You will see why. But also AC can be employ capacitors and inductors in electronic circuit, allowing for a wide range of applications. Right? Can use capacitor and inductors. DC we cannot. Okay, let's go briefly over what you have learned before in your IGCSE transmission. In Malaysia, the same Britain network of cable called National Grid links all the power station. Is allowed demand for electricity to be shared out between power station. Most of the cable in the grid system are carried overhead by pylon. Underground cable are more expensive and difficult to maintain. They are used in cities and where the scenery must not be spoiled. Okay, we got power plant, generates electricity. The power generate P and the root mean square voltage V. Then transformer to reduce To reduce the power loss in cable, the voltage is step up. Right? Step up the voltage, P is constant, you reduce the current in the wire. To reduce the current in the wire, energy loss in transmission will be in the cable will be less, right? Power loss is I square R, right? When the current is small, energy loss is small, right? This is a pylon. Step down in stages to the requirement of the house for industrial use. Advantage of electrical energy. Electrical energy is the easiest form of energy to transmit and distribute by cable. For many appliances, electrical energy is the only form of energy that can be used. Electrical energy can be converted efficiently into any one of the other forms. Right? This efficiency is at the site only, at the place only. Right? Generating depends on how you generate it. There will be power efficiency, power energy will be lost somewhere. Advantages of AC transmission. Direct current is less easy to generate than alternating current. Alternating current is more easy to generate. Alternating EMF are more convenient to step up and step down. That's the advantage, can step up and step down. This reduces energy loss in cable. Alternating current is just as suitable for heating as direct current. Right? Heating doesn't depend on direct current alone. Alternating current is suitable. Heating effect does not depend on direction of current flow. Lighting, filament lamp depend on heating effect. So gas discharge lamp run as well on alternating current. Small motor in vacuum cleaners can use AC. Okay, let's go to our syllabus. Characteristic of AC H2O1. Right? This is called direct current, doesn't change. This is called alternating current, sinusoidal. This is called pulsating. It's a direct current, but it's pulsating. It's not constant. This variable, keep on changing. Okay, you need to know mean value, how to find the mean value. Right? This is your graph or your curve or how the current changes with time. So if it repeats itself, we just look at one period. So we take the area of this rectangle, which is the mean current, equals the area under the graph. Okay? This is represent for math student, but we don't need to use math. We just need to use area of rectangle ABC equals area under the graph. Right? This formula is for info only. Yep, there's the area rectangle ABC. Okay, that's the shape of a cos graph, inverted cos graph. Right? There's a B, there's your A. Area under the graph, that's the area under the graph. Right? You don't need to integrate. It's just to help you relate to your maths. And the mean V, area rectangle, mean V times your period, that's your period. Right? Because area rectangle. This is a symbol for average or mean voltage. Right? We are different from maths. Don't know why they disagree with each other. Okay, determine the mean of the curve shown. What's the mean for the sine curve for voltage? What's the mean value?
Mean value. Average.
Average value, no? Think of this as a hill. This is the valley. We cut the hill to fill the valley. So what do you get? Ground level, no? Zero, no? Yeah, zero. Right? Same power, same graph, but I now displace it. This is zero. This half P naught graph. This is P naught. So what's the mean value? Same idea?
Zero. Oh no, half
Half P naught. Half
half
P naught. Take
half
this
BO, yeah.
hill, place it in this valley there.
Yep,
If
half
they will help
BO.
you, the half P naught. Okay. AC current generators as the coil rotates in the magnetic field at constant angular frequency omega, it cuts the magnetic field and an alternating current is induced in the coil given as I naught sum omega t. Right? Some book will use small I to show its alternating current but your syllabus doesn't require it. You can put capital I if you want to. Right? This is your direct current characteristic of AC. Current flow in one direction only and constant in magnitude. This alternating current. And alternating current is an electric current that periodically reverses its direction in the circuit with frequency depending on the constant of the circuit. Right? This is determined by the generator and the frequency. Okay, now the term same as waves, no different. Peak or maximum current, right? I naught or Im is the amplitude of the current. One cycle is one alteration, right? That's one cycle. Frequency is the number of cycles occurring per second. Period is the time to complete one cycle. That's your period. Same as wave, no different. Right? That's the amplitude. T is 1 over F. Right? That's the equation for this sinusoidal current. Equation of sinusoidal alternating current. Instantaneous current is the current at any time T given by the formula that F is the frequency of alternating current. Right? It can be found in the syllabus. You can use I or you can use V, same thing, same formula. I naught is the maximum of peak current. T is the time. Omega is the angular frequency, same as simple harmonic motion, right? 2 pi f or circular motion. The name may be different, that's why I call angular frequency or angular velocity. It's the same thing. Right? You need to sketch a graph. If you need to sketch a graph of alternating current of 10 ampere, 50 hertz, and then what's the equation? Right? That's the general equation. Find the period first. 50 hertz, how many? What's the period? 20 millisecond. Let's draw it up. 20 millisecond. That's your current. This time in millisecond. That's good enough. Omega is 2 pi over t. Okay, that's your equation. Anything need me to clarify?
Mm.
Find a
All
period.
right.
That's the first thing. And then draw the sine graph. Sine graph and then put a value for that. Amplitude is 10. Is 20, so this is 10. Okay,
Mm.
these are digital power generator oscillator, which you can find in the physics lab. Provides alternating current of different frequency and amplitude. Right? Not 50 hertz only, can be quite high, can be quite low. And then you change the frequency amplitude. Right? So this is your alternating current source. This analog. Other name oscillators, low voltage AC, power generator, provide different waveform in the form of a alternating current, allow different frequency amplitude of sinusoidal waveform to be selected. That's the symbol. Variation in voltage. Right? Some textbook use this one, but this is a standard symbol that you should recognize. Right? These are various forms. Of course, we are not interested. We are interested in these two only, not these two. Okay, but as I say, there are various forms. Besides this one, you got others. Okay, AC flow in a resistor. We are interested in resistor, that's all. Not inductor or capacitor anymore. There is a STPM. Right? Voltage source provide V0 sine omega t. Current through the load. Right? See, same as your current DC using the same formula V over R. Right? So it's V0 sine omega t divided by R. This is I0. Current and voltage are in phase. Exactly the same formula. Right? Magnitude different, that's all. There's your sine curve for this equation. Power dissipated in resistor. Instantaneous power developed across the resistor is right? Same formula. You use the same formula. Replace your I square with this one. Right? So you got I naught square times R, which is this one, no? And this is the square, no? Right? That's what you do. This is your P naught. Right? That's the graph. You square this one, it becomes positive. You square this one, it becomes positive. You square this one, it becomes positive. Right? Where P naught is I square R is the maximum or peak power. Okay, as we have said, the mean value for this one, if this is the I naught square, the peak value, the mean value, you got 10 milliminutes. Right? The mean value is half of that. So mean power is just, this is called what do you call this one?
Current?
It's got a special name.
I know.
Mean
I
square,
not square.
mean square, mean square.
Or
Current,
mean square.
mean square, peak current. Right? That's the bracket for mean, and this I square times R. This half I naught. Basically, you don't need to worry about the math involved. You just memorize the formula. Mean power is equal to half the maximum power. Right? That area is equal to this area. That's the whole idea. That's why it's half I naught mean value. Right? Recall this formula, recall this one, and use it. Don't worry about all this derivation. This for good student in case they want to crack their head. Right? Not required. Okay, remember, you got a sine curve, you square it, it's still sinusoidal. Right? Except it changed, the formula changed to this one, that's all. When you sine square it, right? Sinusoidal, it's not sharp point here, it's still sinusoidal. Right? But this is 2 cycle already for this one. Sine square x graph is 2 cycle, whereas this is 1 cycle for sine x graph. Right? Must remember that. Remember, squaring a sine curve give us still a sinusoidal curve. Okay, root mean square current. Right? That's your root mean square current times R. Right? It's called root mean square current. For DC, we use P equals I square R. For this case, DC, I square R. So we make this power, mean power, equals to P. That's how we calculate our mean power for AC. Right? So it's equals to I naught square over 2 times R. And these two are equal. Okay. These two are equal. That's why we make it to be. So these two are equal. Don't worry about derivation. Memorize it. This formula, root mean square is I naught over root 2. Same with V. V root mean square is V naught over root 2. Root mean square current is the AC current that has the same heating effect in a given resistor as a direct current. Right? This root mean square and this current, direct current and root mean square current have the same heating effect in the resistor. That's how we define a root mean square value. Memorize it. Right? This formula is only for sinusoidal. Recall and use. Heating effect. Heating effect in resistor is proportional to current square I square R. Value of alternating current is always positive, right? Because you square it, the negative part becomes positive also for heating effect. Or current move in opposite direction in resistor during each half cycle. Heating effect is independent of direction of AC. Right? Basically, heating effect is due to electron colliding with ions of the conductor and transfer kinetic energy to the atoms. That's all. So whether it's one direction or opposite direction, it still will transfer energy during the collision. Okay, okay with that?
Yeah.
How to calculate root mean square current? Now this one you need to remember. Because it doesn't have to be sinusoidal. First thing, you read from the back. Current, you square the current first. Right? Start from the back. Find the sum of the square of the quantity. You want to find mean, but you square the current first. Right? You square the current first, add of them. This is for discrete current. Right? Just to suggest to you, this is the sum of the current square. Sum of current square. Find the mean of A. right? We call mean square current. Mean square current is this one divided by n, number of discrete elements. And root mean square, you just square root it off. Okay? You won't be, you will require to use it on graph lah. This
Okay.
idea. But you won't be tested on this idea lah. I mean this equation, you won't be tested lah. This equation is just to help you understand that's all. Right? AC ammeter, use heating effect of current to measure the root mean square current. Okay? It's written there lah. Alternating current there lah, the curly sign lah. Normal DC ammeter, the needle will swing to and fro and thus measurement is impossible lah. So you cannot use normal AC ammeter lah. Okay, we have completed. Now as you wait for 15 minutes, try the worksheet lah. Right? Summarize yourself lah. Things that you need to remember. Okay, let's try some question. Let's try this one. For an alternating voltage, V equals to, this is 20 in volt lah, 20 in volt. This one is T in millisecond lah. Determine the peak value, you must know how to read the sinusoidal graph. Peak value is 20 volt, root mean square is 20 divided by root 2. Frequency is 2 pi f equals to 200 pi. Okay with that? So, still got energy for second session?
Can I?
Okay, you have energy, we carry on.
Sure. Well, how long is the next session?
Same
After
40
15?
minutes. 40 minutes.
14?
40.
Oh no, I mean like how long until you can start the next session?
15 minutes break in between.
Oh, 15 okay.
15, you can use that to try the question before I go over with you.
I take a shower first lah.
Okay. Okay, what is the peak voltage here?
Peak voltage, 325,
Okay, good. Frequency?
20,
In this period, then
0,
you have to calculate the frequency. Root mean square voltage?
0,
Root mean square voltage?
0.
No, use the
Oh,
formula. 325 divided by
oh,
root 2.